Hello and welcome to another Unity C# tutorial. Today I'm going to be showing you the first part of a tutorial for making a third-person platforming game. We've done a lot of platforming game stuff before with our little character moving around. We made a first-person character controller, we've made a third-person character controller. So some of this stuff will be familiar to you. However, this time the end result is going to look a little bit more sophisticated, I think, and hopefully will help you produce the 3D platforming prototype that you need to. Here, for example, we've got a third-person controller with our camera moving around this character. Whenever we move around, we animate our character, and we can move around, and we're moving with the left stick here relative to the camera angle. Also, you can see the character moves slowly and animates slowly as I move my left stick slowly, and then accelerates depending on how far I move my stick. That's something we'll be doing. The character faces the direction we're moving in. Finally, I've got this jump, which animates nicely as well. It sort of goes into this loop where when you're falling, the animation loops over and over again, and then it knows when to trigger the start of the jump animation and the end when the character lands. And there's a couple of different other things that we're doing here to make the movement a little bit smoother, so that we can create this character that can run around and platform. And this will be the basis for your own prototype. So if that's what the final version of the prototype from the tutorial will look like, let's start with humble beginnings as always. We're going to go ahead and create some objects that we can move around. Before we have an animated character, we have to have a character that just moves around. So let's start by creating a 3D plane. It's a classic. Always start by having a 3D environment to move around. I'm going to go ahead and create a 3D object, which will be a capsule. Actually, no, I don't think I will make a capsule this time. This time, I'm going to go ahead and make a cylinder instead. Now, the interesting thing about the cylinder is it actually does, in fact, have a capsule collider on it. If you have the gizmos turned on here, by clicking on gizmo, then you can see there's like this green outline. If we turn off the mesh renderer, you'll be able to see that the collider that comes with our cylinder is, in fact, rounded around the edge. Sometimes this can create, though, problematic behavior with platforming where you sort of like slide off the edge of something because the corners of the cylinder collider, while very simple and easy to calculate, are not quite right. So one of the first things I'm going to do for this particular platforming, and this is sort of up to you if you want to do this or not, you can experiment with design. I'm going to get rid of this capsule collider and I'm going to replace it instead with a mesh collider. And this mesh collider is going to be much more complex, but we've only got one of them, so it's not going to be the end of the world for our frame rate. And but it's going to have a totally flat bottom, which means that you'll be able to sit on the edge of objects or fall off them, but you won't have that sort of strange middle ground, which I much prefer. And I'm going to turn back on this render again. So if this is going to be our character, the one other thing we're going to try and do is make sure that the scale of our character is right before we do all of this velocity movement stuff. So 1 unit in Unity is usually 1 meter. The average person is 1.7 meters. I mean, there's obviously give or take there, but I'm just going to go ahead and make my character scale 1.7 on all the axes. And this is just a quick, cheap and easy way of trying to set up your physics so that the physics look good. I'm going to make this plane a lot bigger so we have a bigger environment to move around in. And my goodness, that white is just blinding me. So I'm going to go ahead and create a material. We'll call this the ground. And we're just, create something that's maybe nice pastel color so that it's nice on the eyes. We'll do something similar for our character. I just used Control D there to duplicate the material quickly. Drag the material onto the character. All right, I think that's easier to see the contrast of now. I'm going to move my camera up. So we're going to do some third-person stuff with this camera later, but for now I'm just going to move it up and look down at the player. So this is probably all familiar to you by now. You guessed it, we're going to add a rigid body to our collider. For this version of the game, we're going to use a rigid body. for where the character moves around. And then we're going to go ahead and attach to that rigid body a new script, which will be our player controller. To prevent our character from falling over, we're going to constrain our rigid body. Now, we don't want to freeze the rotation on the axis that we can, so that we can rotate the character to face the direction they're walking in. And you can't really see it because it's just a plain cylinder, but I'm rotating that, as you can see here, on the y-axis. So I'm going to lock its rotation on the x and the z-axis. That way it can't fall over. And we're not going to freeze its position because we want it to be able to move around the environment. So I'm going to open up my player script, and I can see here that it's currently blank. If I run the game, my character should hopefully just fall onto the ground. No, they fall through the sky, and that's because I've forgotten the mesh collider, for some strange reason, automatically is not convex, and that means that it's sort of facing inwards, which means that we just need to go ahead and tick this convex button so that our collider is facing outwards from the center of our character, so they'll be able to collide with the ground. There we go, and we don't get that silly error anymore. So our character falls to the ground, all very good. Let's go ahead and start making some movement. So to move our character, we're going to have to take input. One of the ways that we can grab input is by, let's see, we can grab input by getting our axes, and by using axes for left and right and up and down. So I can do input.get axis. Will this autofill for me? There we go, get axis. And we can get the name of an axis, for example, on the horizontal. And the reason this is good is because in Unity's input, we can set up this horizontal axis as a value of 1 to 0 to be either use your controller, so you've used your left stick on the controller, or WSD, and both of those values will come through whenever we get the axis horizontal input. And we can actually set that up by going to Edit, Project Settings, and we can click on this Input tab, and we can see all of our axes. The horizontal and the vertical axes are already set up for us. Here's the WSD version, so AD for this, and SW. In fact, also up and down arrow keys as well. And then there's another one called horizontal, which is for our axis. So this is all set up for us, which is great. Now, one of the things we've maybe been doing before is manipulating our rigid body in the fixed update method, void fixed update, instead of our update method. And that makes a lot of sense because we want to update our rigid body. And speaking of which, let's make the rigid body class variable now. Rigid body for use. And so it makes sense that we want to do things to this rigid body in the fixed update because this happens every physics frame. However, if we get our input every physics frame, as we've maybe done in some other tutorials, that means that there are some frames where the physics aren't being rendered, but our input should really be stored temporarily so that the next frame that there is a physics frame, then we get that immediate one-for-one sensitivity, right? So just to make things really, really immediate and really responsive, we're going to store our input in the update frame and then use that update for our rigid body in the fixed update. And this will also make a lot of sense when we try and jump, and we want to make sure that we don't lose our jump input in a frame that the physics isn't rendering, because we want to pick up that input every single time we press the jump button. So I'm going to go ahead and create a public float then for our Y movement and our X movement. So I'll call this move X, and this public float will be move Y. And then we can set these values, move X and move Y, to our inputs in our update method. So the Y will be vertical. And make sure that you spell these, the names of the axes that we're getting. Make sure we spell them correctly, and we can see what they should be in our settings here. So I can see this one's horizontal and this one's vertical. So I could even copy in the name here and see, look, I had misspelt horizontal. So I've brought that in from the actual name of how it's set up in Unity's input mode. So I can't move my character around yet because we aren't actually affecting our rigid body. Oh, so let's make our, let's save our changes. I don't think I saved my changes because I couldn't see the public variables. There they are now. Move X and move Y. And now as I move my joystick, my left joystick around on my controller, I can see these values change. Now, if you don't have a controller to plug in, if you have like a 360 controller or an Xbox One controller, you can plug those in with a USB, a mini USB. But maybe you don't have that all set up, that's fine. We can use WSD now as well to change these move X and Y values. So either one works. The next thing I'm going to do is set up my rigid body. So I'm going to drag my rigid body component into this variable. So now it knows, now this variable will know what rigid body we're talking about. And now we're going to add our movement to our rigid body. Before we've done this by setting the add force, but we're going to do this a bit more arcadey because we want it to be really responsive. So we're going to set the velocity directly, which I think we might have done before as well. And in this case, I'm going to create a vector 3, which is going to be our new temporary value for our velocity. So new velocity. And because I'm declaring the variable type here and then the variable name here inside our method, that means that this variable will only exist. It will keep getting remade every single time this runs, and then it will disappear. So it's like a local variable. It only exists for the duration of each time this method is invoked. So we're going to have to make it a new vector 3. So the first thing we're going to do is set our new velocity to the current velocity of our rigid body. That way we retain all of the velocity that we already had, right? So if we're jumping or if we're falling, then we retain all of that velocity. And then what we can do is we can set the new X and Y values of our new velocity. So we can set X and we can set that equal to move X. And let's go ahead and multiply this by good old time.delta time. So it's frame rate independent. And we'll multiply this by movement speed as well. Now, movement speed doesn't exist yet, so we'll have to make that a public float variable. And that way we can control how fast we move. And let's go ahead and do the same thing on the, now you would think on the y-axis, but remember we're going from 2D space of the input is essentially on a 2D plane because it's only two axes X and Y. And we're going to 3D, and the y-axis in 3D is actually what we're going to use for our jumping, going up and down. So we actually want our y-axis of input to change the z-axis of movement. I know that's a bit confusing, but it's basically like, you know, we want to move it as if it was we were looking straight down on it. That would be the 2D nature of our 3D movement. So I'm going to go ahead and make the y of our velocity equal to the move z. Oh, sorry, the move y. I said that wrong. I'm going to change the move z to be equal to the move y. It's hard to speak sometimes. And the whole point of this is we can leave the y value of our new velocity so that if our character is falling, then we don't override that. We calculate that via our physics. So now we can just set our velocity equal to our new velocity. So our character should hopefully be able to move around so long as I actually set our movement speed to something. I'm going to try setting this to a very high value, to 400. That seems to work well enough. So here's our character moving around, and we can test our the fact that this still works with physics by creating a 3D object cube for our character to stand on, and we can make them fall off the cube. And that way we can check that they are able to fall off things the way we kind of intend this to work. So I'm going to make the cube. I'm going to get my character to spawn on top of the cube. So they're going to hopefully fall on top of the cube. And now, oh, I forgot. I changed my movement speed during the play. I have to make sure I change it in between playing the game, or else it will lose the saves changes. And there it goes, falling off the side of our cube, and it can no longer get back on. So that seems to be working quite smoothly. So it's retaining our y-axis movement, which is good. Now let's go ahead and add our jumping. And for this, we're going to go ahead and create a bool, which is going to be our jump input. And again, just like before, we're going to save our jump input in our update frame. So in this case, we're going to do jump input is equal to input.get. Now I'm going to do get key down because I want to I only want the character to jump when I press the button. So if I press the A button, I want them to jump, but I only want them to jump once. I don't want them to keep jumping so long as I have the button down. So then I'm going to do keycode dot spacebar for jumping. Now in this case, we've sort of hard coded in using spacebar to jump. So if we're using a controller, I'm going to go ahead and add this OR because we want two different ways of jumping. And in this case, we're going to say we can use button 0, and joystick button 0 is actually the A button. So if it's either, so this is what this OR means. So if either this is true, which means we've jumped by pressing the spacebar, or we've jumped by pressing the A button, then our jump input will be true. Now it will keep being true forever, but what we can do is we can then check in our fixed update if we're jumping. So we can say if we're jumping, if jump input, then we can add velocity to our object to jump it. But in this case, we'll also tell it to stop saying that it's going to jump because we've basically used up the input. And this way, because we've used up our input false, we can no longer jump until we press it again. And in this case, we're going to go ahead and add our velocity to our rigid body. So body for use dot add force. And so I can go ahead and set these variables up. So I've got a couple of different variables that I can use. One of the things that I can use for a variable is just to set the X, Y, and Z values directly. So in this case, the X value for jumping is going to be 0 because we're not moving the X value. The Y is going to be our jump force, which we'll have to determine some other time. That's going to be the value of how far we jump. The Z is going to be 0, and the force mode is going to be force mode dot velocity change. The reason we're using velocity change is because we just want a sharp, sudden burst of movement. We don't want this to accelerate over time. We just want it to instantly jump upwards. This jump force, we're just going to make a float for. So I'm going to say public float jump force, and now we can determine how high we should jump. So I'm going to go ahead and save this scene. I'm going to check and see how high, what should my jump force be? It's probably going to have to be something quite large, or maybe not. I don't know. Let's try 6 for our jump force. So now whenever I press spacebar, our character is going to jump in the air. And because we're not overriding the y-axis value of our movement, every time we move around, we can move around while we're jumping, and we retain the value of our jump. Now, here's a problem at the moment, right? I think we've had this problem when we were making this jump before, which is that our character can now just jump forever. So we're going to quickly implement something we've done before, which is we're going to have our jump, our is grounded check. I'm going to go ahead and create a new 3D object. Let's go ahead and make this a cylinder as well. Do the same thing we did before. I'm going to go ahead and remove this capsule collider. We're going to add the mesh collider. Make sure we make this convex. Bring it down a little bit. And this is going to be the thing that determines whether we can jump or not. I'm going to bring the scale of it down. So it's just a sort of little platform underneath the character. And I think what I'll also do is actually just scale it in a little bit, just so that there's more leeway on the character than there is on the jump. So we can't like jump on the side of objects. Finally, I'm just going to go ahead and turn off my mesh renderer because I don't want you to be able to see this. I just want this to be something that we compute. And I'm going to turn isTrigger on the collider so that we can add our grind check script, which will react to colliding with things. So for our grind check, we're going to have to add our collider. So on trigger enter is going to be what we're going to use. We can use our autofill and just hit enter and on trigger enter, which will autofill all of this out for us, which is lovely. So we're going to have a bool, but we want to keep track of everything inside our player controller. So I'm going to create the bool here. Player bool, public bool is grounded. And when we trigger with something, we're going to say is grounded is equal to true. But because the bool is being stored in a player character, or player controller, we're going to have a reference to the player controller here. So I'm going to make a new one. So it's going to be public player controller, and we'll call this controller. And then we can access the is grounded variable of that player controller by saying controller dot is grounded is equal to true. So we're accessing this variable of this class through this variable. And we'll just do the opposite, which is that whenever we exit, is grounded is equal to false. Finally, we're going to set up the relationship. So we're going to go ahead and, oh, it's got an error for us. What doesn't it like? Is grounded doesn't exist. I've probably spelt it differently. Let's see if I build, does it give me an error? Error, oh no, the error goes away. So make sure you guys are building sometimes just to make sure. There I hadn't saved each of my files. So one file was saved, but it was looking for something in the other which wasn't saved yet. I just need to make sure that I go build solution or Control-Shift-B. And that will make sure that there aren't any problems with saving out of order or something like that. Now I'm going to drag my controller into here for the player controller variable. Make sure, guys, that you have your cylinder that's the grind check cylinder. I'll rename this to grind check. Make sure that it is on a child of the cylinder so it moves with it. So now we can see our grind check should be equal to true, and whenever we fall off, it should be equal to false, and then it should be equal to true again. When we jump, you can see it's equal to false every time we jump. Perfect. Now all we need to do is add a check into our script so that we only jump if is grounded is true. And this is all probably familiar to you from previous tutorial, but this is the starting point for our character controller, as always. So not only is jump input true, but also if is grounded. However, we could do it that way, but then our jump input would still be true. So actually, we're going to put another if statement inside here to check if is grounded. Because otherwise, if we press the jump input and we aren't on the air, then it will immediately jump the moment we're back on the ground, and we don't want that. So we do want the input to be used up even if we aren't able to jump. So now hopefully we're able to jump, and we can't jump until we hit the ground again. All right, this is looking good so far. We've got our character moving around. Okay. So let's go ahead and try to work out a couple of additional things before this first simple tutorial ends. The first thing we're going to do is we're going to move our character, rotate our character so that they are facing a particular direction. Now, at the moment, our character is this cylinder that doesn't really have any discernible facing. It doesn't have a front. We will import our own animation and our own character into this so that it does have a front. But for now, let's just indicate the front of the character with a child cube, so that this could be like it's the direction it's facing. Now we could do other things, like for example, one of the things I could do is make it a bit shorter and then put this on top of it. So this could be like the head. We could make a smaller cube that's the neck. But really the point here is just to have something that indicates what direction it's facing. So we can make it sort of stick its face out. I don't know. You can maybe make something that's cool, but really the point is just to create simple shapes, because we're going to replace this with our own little animated character in the future. This is just to show that it's facing. I'm just going to turn off these box colliders on the box so that we don't have to worry about that messing with anything. So yeah, at the moment our character just moves around and faces the same direction as they move. So let's change that so that they rotate to face the direction we're moving. So one of the things that we can change is our transform. So I'm going to do this at the very end of our fixed update. We can change the transform, and whenever we do transform like that with a lowercase t, we're actually just quickly accessing the transform that this script is attached to. And there's a forward value, which is a vector 3. And if we change the forward value, then we can set the rotation. To do this, we're going to use a vector3.rotate towards static method, and it takes a couple of different arguments. The first argument is the current rotation, which we can just feed this in as well, because the current rotation is the current forward that we're now about to change. The next thing we're going to do is set the new rotational value. In this case, we're going to have to create a new vector, and we'll call this rotation. We'll call this new rotation. New rotation. And we'll make that in a moment. I know it's going to complain because it doesn't exist yet, but we'll make that. And then we'll do good old time.delta time for the last one, which is by how far it should move, multiplied by our rotation speed. And then what's the last thing it's looking for? The last thing it's looking for is this max magnitude delta, which is something to do with like what's the maximum it can rotate. I'll just set that to 0, which means it's basically a non-factor. So these are two things that we need to make now. It's complaining about. So rotation speed, that's pretty easy. We know how to make speeds. We just make a public float for that one. And now we have a speed for how fast we rotate. And then the new rotation, we need to calculate from our movement. So I'm going to make a vector 3 here, a temporary one called new rotation. Let me just copy this to make sure it's exactly the same name. And this is going to have to be equal to a new vector 3. And so we need to set the new values based on what direction we're moving in. And that's easy enough. We already have our new velocity here. So I can just go ahead and say new velocity.x, 0, and new velocity.z. And we don't want to face the direction that we're moving up and down. You know, we could tilt, that would tilt the character to look up if we were moving, if we were jumping, or tilt the character to look down if we were falling. And I don't think we want that behavior, because it will probably just make our character fall about and it will be a bit weird. So we'll just rotate them via our direction that we're facing on the X and Y. So let's go ahead and run this, and we'll see our character isn't rotating yet, but that's probably just because of the rotation speed being 0. Let's see what happens if I set this to 1. Our character very slowly rotating, so let's set this rotation speed to 10. And now our character should, okay, still very slow. I'm going to unpause, set the character rotation speed to 100. And now let's see, our character is now going to rotate towards the direction that we're moving in. So now we've sort of got this little character that's rotating around. The rotation looks a lot smoother if I use my left mouse stick. If I use my left stick. Here's an interesting problem is grounded isn't true for some reason. Let's see what could possibly be going on here. Yeah, it seems to be working fine. We'll maybe have some little bugs and things to fix later on, but for now this looks fine. One thing I am noticing though is, and one of the little housekeeping things I think we'll fix just before we end this particular part 1 tutorial for our character moving around, is whenever we move diagonally, our character is actually moving twice as fast as they would. And they're also rotating regardless of how far we rotate. So whenever I stop moving, our character will rotate and snap weirdly. Like that. So every time our character stops moving, they'll rotate. And that's because whenever our movement is at 0, 0, 0, our character is still trying to rotate towards 0, 0, 0. But that's not really somewhere you can. That's not really a direction. It's a lack of direction. So we're just going to add an if statement here to only rotate towards something if our new rotation has a magnitude that is greater than 0. So if it's got a magnitude that's greater than 0, as in, is it an actual direction rather than a lack of a direction, the vector 0, 0, 0. And then we'll only rotate towards where we're moving if we're actually moving. So even if we're moving just a tiny bit, so now our character, once they stop moving, then they don't rotate towards some random position. That looks a little better. And the last thing is that because our movement is along the x-axis is one value from -1 to 1, and our rotation on the z-axis is the same, it actually means that we can go twice as fast if we move diagonally. Kind of imagine it like a chessboard, right? If you move one square to the left on a chessboard, and if you move, then that's a certain distance, which is the same distance as if you move up on a chessboard. But the position, the distance between one square and a diagonal square is much greater. Well, it's almost like 1.5 times the amount. And that's a problem for lots of board game design and turn-based strategy designs. Do you allow characters to move diagonally? Sort of looks like they're moving faster if you do allow them to move diagonally. But anyway, let's stop that from happening. So what we're going to do is we're actually going to clamp our movement. So how are we going to do that? Well, what we have here for our input is basically an input that is a vector 2. It's got an x value and a y value. So let's go ahead and create a new vector 2 for that clamped input. Clamped input. And we're going to set this equal to a new vector 2. And we'll feed in our move x and our move y values. So now we've got our new clamped input. Oh, well, it's not clamped yet. So let's go ahead and clamp it. So I'm going to say clamped input is equal to vector2 dot clamp magnitude. And in this case, we're going to just feed it in its own thing. And we're going to feed it the clamped input again. But this time we're going to say the max magnitude it can be is 1. Which means that even if we're going diagonally, it's going to lower the value of our diagonal movement so that it's equivalent to a movement going up or a movement going down, or left and right. And then finally, we can just feed back this information again. So we can just say move x is equal to our clamped input dot x and move y is equal to clamped input dot y. Let's see if this works. So I'm going to build it out. And now let's see. It might be kind of hard to tell the difference, but I think our character should hopefully be moving the same distance in all directions, where before they were moving twice as fast diagonally. I think this looks about right. So that's just another little sort of, that's like a little secret-y kind of thing that people don't necessarily always implement. It's not necessarily always super obvious. Like in old Doom games, there's this thing called strafe running where you can just move faster if you're moving diagonally. So a lot of people who do like speed running in in games, you'll quite often see them moving diagonally to try and get extra speed. So we've got a couple of different new systems. We've got a whole bunch of familiar stuff. I think I'll end the tutorial here though, just part one, just so to give you a chance, just for your first section of this game, to get our little character moving around, jumping around. And then next up, we'll be looking at trying to add our camera perspective, and we'll be doing a whole bunch of new stuff with animations as well. And I think you guys have been doing a little bit of making your own animations already. So we can it'll be exciting, I think, to see you guys get your own animated characters into the game. And we'll get that sorted at some point.